This video is going to be from the beginning of Chapter 9, Calculations from Chemical Equations. We'll begin to look at how we're going to use our balance equations. This video is going to cover sections 9.1 and 9.2. First, a little review back from Chapter 7, where we're looking at molar mass. So we're talking about the sum of the atomic masses of all the atoms in an element, compound, or formula unit. We remember our Avogadro's number, 6.022 times 10 to the 23. And we know how to calculate the molar mass is going to be our grams of a substance over moles of the substance, usually 1. And this allows us to convert between grams and moles of a substance. So remember this conversion factor we began to use in Chapter 7, because this is also going to be important in this chapter as well. So we're going to learn something called stoichiometry, and it's going to be the area of chemistry that looks at quantitative relationships between our products and reactants in our balanced chemical equations. Anytime we're looking at these questions, make sure you see coefficients. Otherwise, our stoichiometry connecting these products and reactants is going to be inaccurate. So here, for example, we're looking at our a sort of skeleton chemical equation with our little lowercase letters being our coefficients. So if I wanted to know how many grams of A we are using, how much C will be formed? And in order to answer these questions, we need to know that things are balanced, and we'll begin to use these coefficients as a new form of ratios. So our mole ratio, looking at this balance equation where we're taking 2 moles of hydrogen gas plus 1 mole of oxygen gas, giving us 2 moles of water. And we can use coefficients here to make any ratio of a product or reactant together. So here we have 6 different possible molar ratios. We have hydrogen to oxygen, hydrogen to water, and we can use the reciprocate of all of those. Using these ratios, we can now figure out if we start with X amount of hydrogen or X amount of oxygen, how much water are we going to get? So we can use these molar ratios to do questions like the following. If 4 moles of oxygen are present, how many moles of H2O could possibly be formed? So we'll always start with what's given. We're going to start with 4 moles of oxygen. Our molar ratio, based on our coefficients of the question, are going to be 2 moles of water to 1 mole of oxygen. And again, pointing out here, we know that moles of oxygen needs to be in the denominator because they need to cancel out. So we'll get 4 times 2, or 8 moles of water. Here, let's try 2 more practice ones. The moles of water produced from 3 moles of carbon dioxide. So we're going to start with 3 moles of carbon dioxide. Again, figuring out our ratio, we know carbon dioxide needs to be in the bottom. Water is going to be on the top because that's what the question's asking for. That's going to be the mole ratio used here, giving us 6 moles. And so again, remember that the desired quantity needs to be in your numerator, and your known, or what's given, is going to be in the denominator. Let's look at this. Moles of hydrogen needed to produce 3 moles of water. Here we're going to start with a product and end up with a reactant, but the process is going to be the same. So here we have our 3 moles of water, which is given again in the question, multiplied by, again, our ratio with 2 moles of water being on the denominator. Clear just multiplication, divide by 2, giving us 6 moles of hydrogen. So it's basically looking at how we can increase the entirety of the ratio of our coefficients. Here's a checkpoint that you should work on your own. Please pause the video now. Okay, in this one we're starting with 0.5 moles of oxygen, and we know we need to go from moles of oxygen to moles of aluminum. We'll start with 0.5, multiply by our 4 moles of aluminum over 3 moles of oxygen, our coefficients from the above balanced equation, giving us 0.67 moles, or B. We'll continue to look at these questions starting with grams, or maybe going from moles to grams, and eventually going from grams to grams. So we'll need to continue working on molar masses. But to start, identifying molar ratios is the important part of Chapter 9.